What's going on, guys? Welcome to your 6th Java game applet tutorial. Again with me, Travis. What we're going to do in today's tutorial is add some physics to our game, make our ball look a little bit more realistic. What do I mean? Well, I'll just run it because I kind of programmed it, and this is what we're basically going to be doing, and this tutorial might take one more tutorial to get something like that. So a little bit more natural movement of our ball, and add some friction to it, stuff like that. So what we're going to need for this tutorial is to change your dx and your dy to be doubles instead of integers, and set your dy to be 0, set your dx to be 0 just for testing out our gravity and all that stuff. The next thing that we need to do is we need to set up some kind of a gravity. Again, it's a double, and we're going to set that equal to be 15 to start out with. We're also going to set up a double, which is energy loss, and I'll explain what that is here and as we program. And lastly, we need to set up a change in time variable, or a dt, basically the step amount that we're taking. We're going to set that at 0.2. So get your variables set up just like that, and we should be good to go. The next thing that we want to do is we want to delete everything that we did for our y. So go out down to our run method, and everything that has a y or a dy, delete all those if statements that we created for our last tutorial, and we're going to recreate it bigger and badder than we did previously. So the first thing that we need to do is set up kind of a familiar if statement, and you're going to be like, what? Why did we just delete this? And I'll be like, hey, shut up. We're going to say if y is greater than this dot get width, get height, and minus the radius minus 1, again for the same reasons as before. So this is if our ball is at the bottom of the screen. If we hit the very bottom of our applet, well, what do we want to do if our ball is bigger than our screen, or if it's below where the bottom of our applet is? Well, we want to set our actual y position to be at the bottom of the screen. So again, we're just going to say this dot get height minus radius minus 1, and then what else do we want to do? We want to change the direction of our dy. So we're going to say dy is equal to negative dy. Now, what some of you guys might be thinking already is, hey, we set up our dy to be 0 at the beginning. Why is that? Our ball isn't going to move at all. Well, the reason that we did that is we're going to allow gravity to change our dy for us. Think of it as if you're holding a ball in the air. You just let go of the ball, your dy, or your change in y, is going to be 0, and then gravity is going to pull that ball down and make our dy a larger number. Whereas if you had a ball and then you threw it up in the air, the second you released it, you'd have given it an initial dy, whether that be a negative or a positive. It would have been some initial a dy, and then gravity would obviously act upon that force as well. But for just testing it out, we're going to set a dy as 0 to start out with and let gravity do its course. So now that we've set up basically what we want to do when our ball hits the ground, we also want to move our ball when it should, or allow gravity to act upon it. So we're going to add an else statement. So if it's not at the bottom of our applet, what are we going to do? Well, we need to have some sort of a movement. We're going to be using a physics formula. If you guys don't know physics, that's cool. Not a big deal. I should be teaching it pretty soon. This is just a physics formula to show the position over time. So we're going to have y is equal to y plus dy plus 1/2, or 0.5, times gravity times dt squared. You'll see that in physics quite a bit when you're working with movement and stuff like that. So don't worry about that. That's just basically, I'm going to go up above and leave a comment, that's position. It's a position formula. So now that we have our position formula set up, even though it's giving us an error, so instead of saying y is equal to y plus, we're just going to say y plus equal to, and then we're just going to delete that there. So it's basically the same concept. And now let's save this and run it, see what we get, see what improvements we need to make. Obviously our ball isn't moving anywhere, so that's a problem. So what we need to do now is set up our change in y, or dy, and we're going to set this equal to be dy plus gravity times dt. Again, another physics thing. If you guys don't understand what I'm saying, that's cool. It's just a formula to figure out the change in velocity. So we're going to have dy plus equal to gravity times the change in time, or the dt, and we're just going to say velocity formula, and there we go. So let's run this, and hopefully we get a bouncing movement. And as you can see here, it bounces naturally like you'd expect a bouncy ball to bounce off the ground. It gets faster as it's going down, and then right after it hits the ground, it has a pretty fast speed going up, but that slows down and turns around over time. So you get this kind of a bouncing movement. Awesome, right? Only thing is it's still not realistic. It looks a little bit better than before, and not to get too much into the physics, but when a real ball in real life hits the ground, it loses some energy because of that impact. It gives off some heat, or it spins the ball, which loses some of the energy, which makes the ball not be able to bounce as high as where it started. So you lose some energy each time it bounces until eventually it just starts rolling. So now let's simulate that within our program. So the first thing we have to think about is, when is this ball going to hit the ground? Well, we know that. We know that it's going to hit the ground if this if statement is true, because this is where we set our y value and we change the direction of our dy. So now what we're going to do is we're also going to take our dy, whether that be 20 or whatever it is, right when it hits the ground. Instead of flipping that to negative 20, let's try and flip it to a negative 18, so it doesn't have as much speed upwards as it did when it came downward. So we're going to have our dy equal to be dy times like 0.9. So that's what that's saying is, if our ball had a speed of 20 right before it hit the ground, we had 20. So now what we're going to do is we're going to take our 20 and we're going to times that by 0.9 or 90%, and that's going to be 18. And then we're going to switch the direction of our speed so it goes upward. So it's going to be negative 18. That's what we want. Instead, we're going to change the format as well, so you guys get used to doing it this way. It's quicker programming, and it's easier for people to read once you understand this kind of methodology. So all we're going to say is dy times equal 0.9, or to use our variable, we're going to say energy loss. So that's the concept that we're using there. Now when we run this, we get something like that. So that's cool, right? Perfect. As you can see, our ball's still kind of moving a little bit, so we're going to fix some of that stuff in the next tutorial. We're running out of time, so hopefully you guys enjoyed it, and even if you don't understand the physics of it, that's all we're doing, is we're adding some real life physics to our game. And thanks again for watching, guys. Catch you later.